Okay, let's do some 5.5 problems. I assigned problems 4, 6, and 8. I don't want to use any of those, so let's go to the next even number, problem 10. Let's go over here, back to my worksheet, copy and paste, and we are doing 5.5, all right, and problem 10. And what's the problem here? ty double prime plus t minus 1 y prime minus y equal to 0, and one of the solutions is e to the negative t power. Let me check if I copied the problem correctly. T double prime plus t minus 1 y prime minus y is equal to 0, and one of the solution is e to the negative t power. Okay, all right, let's begin. Okay, here y2 is u times y1, and y1 is this one, by the way, but we're gonna do this later. So y2, the derivative of it is by product rule u prime y1 plus u y1 prime, just product rule. Alright, how about the second derivative? y2 is equal to, and we have to use product rule to this one, so u double prime and y1 plus u prime and then y1 prime, product rule, and another product rule here, u prime y1 prime, which was there before, plus u y1 double prime. And these two happen to be the same, so we can put those two together into twice of that. And are we ready? I guess so. Let's plug everything to the original equation here. So t times y double prime, so it's this one we are doing, plus t minus 1, and the y prime, we are putting this one in, minus y, so we are putting this one in. So we have to get that. Now what we are going to do is to get all those, use the fact that y1 is a solution of this equation. And one way to do that is to get all those coefficients of u, and then this is ty1 double prime, and u is here, and then y1 prime with t minus 1 and u of y1. So that's what we are going to do. So let's get all the factors of u, and then let's see, this one is gonna give you ty1 double prime. Okay, this one gave you that. Next, this one, plus t minus 1 y1 prime, minus, finally this one. y1. Okay, so that took care of this blue part. And if you take a look at this part, that's equal to 0 because y1 is a solution of this equation, and you get precisely that. So this blue part will turn out to be 0. Now how about the other parts? Well, that's something we have to work on. Let's see. T y double T y 1 u double prime, that'll be this term, and then this one plus 2 t y 1 prime u prime. Did I get that? T times 2 times t and then y1 prime. I got that. And then this one plus t minus 1 y1 and then times u prime. And then are we all done? This doesn't contribute anything, so equal to 0 is what we're gonna get. And all these have what? U primes in there. So let's rewrite this thing a little bit. Let's copy and paste. This is 0, isn't it? That was the design. y1 satisfies this equation, so this one is 0, so this entire thing drops out. This entire part drops out. And then how about these part? U prime part is there. They all have U primes in there. So I can rewrite it like this. And what do we have? We have a first order linear equation. A first order because you have U double prime and then U prime. Let's work it out. Let's copy and paste this thing. Divide everything by this. Then dividing all these by t, y, 1, and let's see. Let me expand this font a little bit. And I guess from here you can find out the integrating factor and work it out. But then again here, from here at this moment, using this y1 as general y1 is not going to be very good. So I'll say step 1 is done up to this point. And then let's go over to the step 2. Let's start from here, the last conclusion. Okay, please remember y1 is e to the negative t power. So that's something I'm going to put in over here. And then over here. And also y1 prime. What's the derivative of e to the negative t? Exponential stay the same. And by chain rule, we have negative 1. So we got this negative sign. Okay, all right. Do you see that exponential is common everywhere? Oh, by the way, why did I work with the previous expression? Let's bring it back. So that's where we started. And then plugging in, we got that. And then exponential is common everywhere. So just remove all these. And further simplification. Negative 2t plus t, so we're going to get negative t minus 1, okay, dividing everything by t. As a matter of fact, I think that was a bit too much. I just have to copy and paste this thing. I'm not rewriting, so there's no reason to just jump ahead too much. Let's keep it, and then let's take one more like this. And then let's simplify -1 minus 1 over t. Okay, much simpler than before, going good. So let's find out the integrating factor. So integrating factor is mu is equal to exponential of the antiderivative of this part, isn't it? Antiderivative of this. I need bigger font here as well. So antiderivative of -t2, so that's -t. And antiderivative of 1 over t, that's log of t. That's the integrating factor. So this is equivalent to e to the -t, and then over e to the log of t using those exponent rules. So we have a cancellation. So e to the -t over t. And as a matter of fact, we can bring that exponential down as well. Okay, that's the integrating factor. Okay, now that we have the integrating factor, this equation here can be rewritten like this. Of the integrating factor times u prime of t is equal to the integrating factor times 0. So we have just equal to 0. Again, I have a lot of fractions here, so I'd like to have bigger font. Okay, let's take the antiderivative because this is really simple computation. Let's just go ahead. 1 over t e to the t power times u prime of t. Oops. U prime of t is just constant. Because antiderivative of 0 is just a constant. And all I have to do now is flip this part over. Is equal to c1 times t times exponential of t, and that is u prime. Almost there, almost there. What I want is u, and then eventually I want u times y1. So okay, if I go ahead with one more integration, then I'm gonna get u. But then again, we have done a lot, so let's copy and paste this thing here. Let's say step 2 is done now. And let's go over to step 3. Okay, this is the antiderivative computation. Okay, this can be done easily with integration by parts. Let's get this constant out. This one can be done through integration by parts. So I'll just use Mathematica to calculate it rather than spending valuable time talking about it. So this can be done through, and then the answer is t e to the t power minus e to the t power. That's the antiderivative, and plus c2. So c1 was there before, the integral constant from previous computation, and then this is the antiderivative, and then we have another one coming. So that's my u. So let's go with the final answer. What is y2? Is u times y1 of t, isn't it? So it is the same as this one over here, which is just calculated, times exponential of negative t. Let's see, this is complete, but oh, wait a minute. Excuse me, I've been too silly, excuse me. What was I thinking? I don't really need all these constants here. I'm not looking for a general solution. All I'm looking for is another particular solution, another solution of homogeneous equations. So I could select C1 as simple as I want. I'll select it as 1 here. I don't have to select it. 0 is not good because I have to multiply. So this should be just 1. So that, okay, that's just 1. 1, I don't need it. So this is just 1, I don't need it. And this one, I'm going to select it as 0. I'm not going to do any multiplication here. So it's okay to take something even simpler than that. So, okay. So I don't need this. I don't need that. So that is my y2. So what do you get? Distribute e to the negative t minus 1. Yeah, that's what I'm getting. y2 is t minus 1. Okay, good. The general solution, therefore, is c1 y1 of t plus c2 y2 of t. And what is y1? It is exponential of negative t. What is y2? As we calculate t minus 1. So this is a general solution, the final answer. And I'll say that is step 3. And let's see if I did it right. A e to the negative t power, and then plus b t minus 1, and then let's put the left hand side of this t times y double prime of t plus t minus 1 y prime of t minus y of t. Simplify. Am I gonna get 0? Yes, indeed. So everything is correctly done.